So by loading it that way, we just load it here and we can say, right, okay, so
wow, here we go.
We can see that with
1,000 amps,
that's
1,000
right.
and a bit.
We'll get to the testing in just a sec. Who doesn't want to play with 500 amps just sitting out there on the bench on some cold winter's morning? I know I do. What you were just looking at there, right, was the most reliable, I would argue, virtually foolproof way to test the health or otherwise of any lead-acid cranking battery, which would be the one that starts your engine every frosty winter morning until it doesn't, of course. Typically when you're already late for something important, a job interview or running back to the getaway car in your balaclava. Shitra. Cranking batteries commonly croak in winter. I think we pretty much already know this. And unfortunately, in the digital age, the high-end diagnostic machines which dealers and mechanics increasingly use to assess battery health sometimes declare your battery to be kind of okay when it's actually just had its final fateful appointment with Dr. Kevorkian. In just a sec, we're going to talk to an actual battery brainiac. He's got a PhD in battery brainy octology. We're going to talk to him about exactly what you might hope to do about that and the best way to test that battery. Every year at around about this time, people reach out to me and they're trapped in this seeming death spiral of being run around. Their car keeps not starting on that stereotypical frosty morning. Pro tip, Americans and flat earthers. The earth is actually a ball, and that means it's the middle of winter down here. So, in these cold conditions, when they go to the mechanic or the dealership, the battery gets a clean bill of health, but it's clearly having a kind of near-death experience. Often, people in this situation are on their third frustrating iteration of the diagnostic process. Lots of head scratching going on back at the workshop kind of thing. So this video is for you. If you are the owner of a vehicle with a cranking battery that is 3 or more years old, which would be the typical age of incipient diagnostic death spiral. Not everyone suffers this, but occasionally, and it can be such a deal breaker. It's also for you if you own a workshop, dude, or you run a service department, because you might not be measuring the health of your customers' batteries in the most robust way. And this means that you could easily start looking like the Keystone Cops as far as that subset of customers is concerned, not to mention jeopardizing the fat stacks of future servicing revenue, which those people are increasingly unlikely to spend with you. The essential problem here is that most battery testers, even the ones locked up there inside high-end diagnostic tools, the ones costing tens of thousands of dollars, most of them just measure the internal resistance of the battery, not its actual cranking performance. Lead-acid cranking batteries sometimes manage to fail in sneaky, underhanded ways, at least at times. And when they do, the battery is completely crapped out for cranking purposes, but its internal resistance still looks kind of okay. And these are the failures that slip through the cracks. At times, you'll be delivering, if you're in that workshop environment, or receiving, if you're the owner, a message that the battery, she's all good, dude, when in fact it's functioning roughly as well as the service module on Apollo 13 on Monday, April the 13th of 1970. Nobody wants that. Main bus B undervolt nasty business. Now, me being a somewhat average mechanical engineer, this is pretty much the limit of what I know on this subject. So to find out more, I trotted off to the dudes at Durst. Durst Engineered Technologies is a niche Aussie manufacturer. So on the off chance that you've got a fleet of trucks with flat batteries or buses or something, up to and including those ginormous Caterpillar 793 mining dump trucks with their 85-litre engines and 250-tonne payload capacity, Durst can provide you with a Hyperstart jump starter for them. And dude, I want to have a crack at that. I so do. It's a sickness. Admittedly, like that pack is a two-handed carry, right? But it's pretty impressive. Imagine breathing life into a dead giant machine of that nature. This is the kind of conduct historically that got one burned at the stake. Not so much these days because, mining, time is money kind of thing. But it's still proper witchcraft, dude. Like hashtag Arthur C. Clarke on that. He had a pretty good quote about that. You can look it up. If you need to charge, 50 batteries every day, like all different kinds, different voltages, different chemistries, whatever, Durst has a modular charging array for you, dude. Sorted. And if you want to test those batteries the old school way by placing them under some kind of heavy resistive load and seeing if the actual amps they're delivering measure up to the spec, you've also come to the right place. This is what Durst does. You won't probably see anything from Durst at Bunnings or the local auto parts store. They're a bit too niche and heavy, hardcore industry for that, obviously. But Durst operates out of this modest but also kind of impressive factory in Castle Hill in Sydney's northwest. And I met up with Frank Luksic there. Frank's got this military industrial aerospace background and he's presently the head of design at Durst. It's fair to say, I think, that Frank is the biggest battery brainiac that any of us is ever likely to meet.
What causes a battery to die?
The chemical decomposition of the cells inside, basically, as the chemicals and as that material inside disintegrate over time. So every time we charge and discharge, it gets a bit weaker and it gets a bit weaker and it gets to a point where it just becomes the chemicals just don't work anymore.
So
simply put.
So in here the plates get oxides on them and other precipitates and things of that nature.
That's right. So sulfation is a thing.
Yeah.
So we've heard about that.
Because sulfuric acid, obviously.
That's correct. Yes, absolutely. Yeah. That's right. So sulfation is a thing where it's just basically a coating over the internal plates inside, and that basically robs the battery of its performance.
Okay. So if I got something, it's always when you've got something important to do, like you've got a christening to go to, or your wedding, or job interview, and it's the middle of winter. You hit the starter, nothing, and then you get a jump start, whatever, and you turn up at a mechanic and or a dealership, whatever, and they test your battery. They typically measure the internal resistance with one of these, quote, high-end diagnostic tools. So talk to me about that and how that works, and then we'll get into why that might fail.
Okay. So it's very common to get a test done in that particular way. And what happens is it does read the internal resistance from A to B in essence. And
so the resistance between here and there.
That's right.
Between there and there.
That's right. Between the plates. Yeah. So inside we've got cells, and we've got 6 cells in a typical battery like that.
Yeah.
And each one of those cells, there's plates between those cells. So we're measuring the resistance from A to B, basically. And there's a known resistance, an approximate known resistance. But that resistance may not always be true depending on the charge state of the battery. So if the battery is fully depleted and it's fully charged, it may not be the same. And then we run into additional problems like things like surface charge. So now we've jump-started the battery and the car's up and running, and we've gone to our dealer, and now the alternator's been charging up our battery, and we get there and guess what? It's at 13 or 13.5 volts, and it looks great, and we get the tester out, and what the tester is actually seeing is surface voltage, right? It's not actually, and that's an artificial charge on the outside of the plate.
So let's just back up a sec. If I go to a dealership or my mechanic and we get out one of these little diagnostic boxes that they put across your battery, it's measuring the internal resistance, and usually that works. Okay, usually
yes.
It works.
Yes.
But it's amenable to different failure modes, as I understand it. Like the operator has to go off and read the battery and figure out the correct cold cranking amps.
Correct, yes.
Right? And he's also got to get the right type of battery and enter that in, like if it's a glass mat AGM type battery, or whether it's gel, or whether it's just a conventional wet thing, he's got to get that in there.
Yes.
And So that's amenable to failure. And you could potentially be that guy who turns up at the dealer after missing his wedding because the car won't start and you're not smart enough to get an Uber, or too smart to turn up at your own wedding, one of the two. And then, you know, the dealership or the mechanic could run the test and potentially that could give you a false positive that the battery is okay because you're not actually measuring its ability to deliver amps on target, right?
Correct. That's exactly correct.
Okay, so you mentioned surface charge before, and I'm only a humble mechanical engineer, so my head explodes when people like you start talking electrostatics or dynamics, whatever it is. What is surface charge?
So surface charge is an artificial, let's say artificial, but it's a high voltage on the external plates. So it's not the absorbed voltage that we typically get on a battery. So we apply a high voltage and then it is absorbed into the battery, into the chemistry of the battery.
So is that why you can get a crook battery and charge it, and then you can get a bit of punch out of it and it dies?
Exactly right.
So it's holding this sort of fake charge on top.
That's right.
But its actual ability to hold a sustained amount of stored energy is kind of already in the crapper.
Exactly right. That's exactly right. So that surface charge only shows a part of the story.
So if I turn up at the dealership with a battery in that state with a high surface charge but otherwise crapped out, and I connect my high-end diagnostic machine, it can tell me that the battery's okay.
It can, yes.
And then I'll go, oh, okay, and I'll bugger off and the same thing will happen next time I try and start.
Exactly right. So what they really should be doing is taking that surface charge off, bleeding that power down, or letting it rest. We don't have time for that, but letting it rest or bleeding it off will give us the correct
But when you say letting it rest, you're talking about me dropping my car at the mechanic and letting it rest for like until tomorrow.
Correct. That's how batteries need to be tested.
That's not like 30 minutes.
No, it's not, unfortunately.
Enjoy a coffee in our lounge.
No, it's
right.
not.
Okay, it's not that. So you are the battery guy, and I mean, your party trick is dead batteries, right? Because this thing here is full of capacitors, and it starts things like buses and trucks and people who've got fleets of mining equipment. Like you got a dirty big version just there that'll start a 793 dump truck.
Yes.
And they're mega, right?
Yes, absolutely.
So basically, your job wouldn't exist if it weren't for a fleet of dead batteries out there all the time, and Durst wouldn't exist because, you know, this is what you do.
This is what we do, yeah.
When I look at this baby, which is a battery tester, I get this Cape Canaveral 1969 vibe, right? I don't get high-end diagnostic machines with LEDs and all of that stuff that we've come to expect. Like, there's no app for this.
There's no app.
In the Play Store.
No.
So what is it?
Well, it's a mechanical tool, right? At the end of the day. And you'll do notice the beautiful sweeping gauges on there. And again, in 2025, do we expect to see this? Well, sometimes not.
I'm not dissing Apollo. Like, the Apollo vibe works for me. Like, we got 12 men to the moon. Come on.
Absolutely.
With analog.
With analog.
Yeah.
And this is a very analog machine. But making it digital is not the same anymore because reading a sweeping needle is half the job here, basically. So when we're loading up a battery, we can see how that needle moves, you know, throughout the gauge, and that gives us a good idea of how good the battery is, even without even looking at a number.
But the substantive difference between this and the high-end diagnostic machine that measures the resistance is that measuring the resistance is like a proxy for the health of the battery, whereas what this type of tester does is it actually simulates the heaviest load the battery's meant to operate under.
Correct.
And then directly measures the performance. This is frickin' Ohm's law in a box, right?
Yes.
So what is in here? What's the big knob thing connected to?
The big knob is connected to specially calibrated carbon plates inside.
Right.
So in this particular unit, there's 2 big carbon plates inside. Many actually, there's 16 carbon plates inside, and they're all
They're in
lined
2
up.
banks of carbon.
That's right,
yeah.
2 banks of carbon
plates. And this
plates.
one's got 1, right?
This
Same thing, but
same
smaller.
thing.
Yeah.
That's right, smaller. And those carbon plates will move up and down, or close and open, depending on how we position our little rheostat there.
Okay.
And as we apply the load, which is bringing the plates together, we are creating a resistive load that is measured and that is controlled.
Yeah, right. Okay, so when I say Ohm's law in a box, you're changing R with your knob, so to speak, and we're applying, we're waiting for the battery to reach a to drop down to the sort of critical voltage where it delivers its maximum performance.
Yes.
And you're measuring I directly. So that battery has to be cranking out the big fat amps through the machine. Like, this is what happens when you hit the starter.
That's
right?
exactly what happens.
This is the
yes.
heaviest starter hit that battery's designed to experience.
That's exactly right.
So when you do this, and we'll do that in a minute to a few of these batteries, but so when you actually do that, there's no proxy for anything. You're actually measuring the battery doing its thing. So
Absolutely.
if I turn up with a battery with this surface charge problem, and this can be so frustrating, right? If I'm an owner of a car and I don't know squat about electrodynamics, and a dealership or a mechanic tells me, she's all good, I'm kind of afloat. I've got to take that at his word,
Yes.
right? So I go back out, the battery fails shortly thereafter again, and I come back, and you could be in this death spiral where they go looking for anything, and they haven't once measured the actual battery performance. So the surface charge thing that we were talking about earlier, what happens to the surface charge if you apply Ohm's law in a box?
Well, we bleed it instantly.
So it's just gone.
It's just gone. It becomes irrelevant with a box like this completely.
So it's okay. So it strikes me that if I'm not the customer now, if I'm a mechanic or a service manager at a dealership, and I measure the internal resistance and essentially fob someone off with a false positive diagnosis, right? That's extremely frustrating for them, to the point where I might not be providing them with services thereafter because they might just crack it.
Yes.
Right?
Yeah.
Whereas if I just trot out the Apollo spec machine, so to speak, then that's not going to happen.
It's not going to happen. No, not at all. Because this will actually give you the true performance of the battery. So we're measuring the actual performance. We're not estimating, we're not guesstimating.
Yeah.
It's a dynometer for your battery, in essence.
Yeah, right. So it is literally a battery dyno.
Yeah, it literally is, yeah.
Because I've known people who've had that problem, you know. It can be, it's so mundane, getting in your car, you hit the starter, and you just expect turning and burning that shortly thereafter, right? And then, because it's seemingly such a simple system, you'd think that a fault this predictable, this likely, whatever, would be easy to diagnose. But do you have any info on how often this kind of false thing happens?
Well, it happens very often.
Really?
It does. It really happens. And a couple of examples. I've been to a couple of dealerships and a couple of sites where they keep on saying, well, we've got the best of the testers and they cost tens of thousands of dollars, and, well, why should something like this do better? And I said, well, let me show you why. And we've had a customer that had exactly that same problem. The car's been sitting in the garage. It's a weekend driver.
Yep.
It doesn't get all the love it deserves as far as battery is concerned. And
Yep.
the battery's gone flat. They've jump-started it and driven it to the dealership in exactly that sort of scenario. And the battery's now charged. It looks great. You know,
Yeah.
they tested the tester on there. Tester says, hey, it's all great. Customer's taking it back home, and 1 week later, guess what? We're in the same position again.
Yeah, sure.
And then when it came back over, we brought the load tester over, we connected it up, and as soon as we applied a load, what was interesting is what we found was that particular battery had a dead cell. And it only comes up when you actually apply a strong load to it. So it looks all great and dandy, and the internal resistance was really good.
So this
but
is
that
an
cracked cell.
Yeah. So this is an intermittent, like, you got your average 12-volt battery's got like 6 cells in there, 2 and a bit volts each, right?
Correct, yes.
So you can have a battery that passes the internal resistance test, but one cell just craps out under load.
Correct.
But is otherwise has integrity.
That's right.
At no load or light
At no load. It looks,
Yeah,
on
okay.
an unloaded battery, it looks great. We can put a meter on there.
Yeah.
It's reading 12.6, 12.8 volts. It looks beautiful. But as soon as you put a load on there, and that's where that cell would fall away, or it cracks, as we say, it cracks open, basically.
Yeah.
But that load is not also, a light load may not do it. So you may turn on the lights on your car and it may be okay.
Sure.
But it's something when the starter kicks in and the battery's a bit weak, that's certainly enough to make it crack open, and then guess what? It won't start. It'll instantly drain the battery. It may even create an internal short on the battery, and then it'll actually basically just destroy it for you along the way.
Yeah.
It'll discharge it instantly.
Okay, so you've got this big old school rheostat here, which is connected to these carbon plates that sandwich themselves in and out and thereby the resistance changes. I'm tipping that if you crank this, we're not connected to anything, if you crank this right up and leave it that way and then connect it to a battery, that's going to be a little bit interesting.
It would be.
All of a sudden you'd be welding.
You would be welding very much so.
Briefly.
Briefly.
Yeah.
You would certainly see what the battery is capable or not capable of.
Yeah, right. Okay, so if you are going to use the old school test, it might be a really good idea to remember to unload the rheostat.
That's right. Always.
After each test.
After each test.
Yeah.
Very important.
Do they need calibration, these things?
They do need calibration every once in a while. We recommend every 12 months if you use it on a daily sort of scenario.
Yeah.
But if you don't, every couple, 3 years, or if you may notice something is out of whack, generally they're extremely reliable. And because the carbon plates and the internal components are all calibrated within one another, they tend to last forever, provided you look after them. But the carbon plates do wear over time, and they can get chipped, particularly if you transport the unit and so forth. And if you're using it, if you're overloading it and you're giving it a hard time every day, those plates will get thinner and thinner and thinner, and that's where we say, hey, let's get it recalibrated.
So this will measure what, up to 2,000 cold cranking amps?
Correct.
Right.
Yes.
And it'll do 6, 12 and 24 volts. So
Yes.
if you've got a truck, you're okay, and if you've got a car, you're okay, and if you've got some, 6-volt appliance, you're okay.
That's right.
But you do have to have some basic ability to read analog dials, which is a bit like, I can imagine there are kids these days who don't look at an analog clock and go, what the fuck is that? Are you up against that at all?
Well, interestingly enough, not really. It's been pretty good. So most people who can read a clock can certainly read the tester.
Yeah.
So we've been okay that way so far.
You do have to pick which scale on the dials to read, though, don't you?
do.
Because I know you've got just amps and cold cranking amps here. So just because mechanical engineer, it's like a deficiency, I know. What's the difference between amps and cold cranking amps when it comes to a battery?
Well, cranking amps is really the true measure, in my opinion, at least, because that's the number that is the actual physical output. A cold cranking amps is a number which is basically rated at 0 degrees Fahrenheit, typically about minus 18 degrees, and that's where the test is supposed to be done at. So
this is like a lab test.
it's like a lab test.
Standard.
It's a standard. So the CCA is a standard as a number, and the actual cranking amps is the actual physical amp output of the battery.
Yeah, okay. So if I flip who the customer is now, and let's say I run a bus company or a trucking company, I'm probably buying batteries by the odd pallet or several of them at a time.
Yes.
What's the failure rate of batteries like when they're brand new? Because obviously there would be some defective batteries getting shipped, and that could be quite expensive. And if you had this, you could test them off the bat and just ring your supplier and go,
Absolutely.
hang on, dude. So what is the failure rate of new batteries like?
More than you'd like to think, actually.
Really?
And consider the batteries that are always made, most of the batteries that we have in Australia, or at least are made overseas, and we'll have brands out of the United States, brands out of China, brands out of India, and so forth. And those batteries travel a long way to get to us. And typically out of the factory, they may not even be fully charged. So it's up to the distributor then to bring them in and then top them up and so forth. And then sometimes the distributor doesn't have the time, or they may not have the ability, or business is really too quick for the day and they have to get them out. And what will happen is you'll have batteries that are at a half charge, and then you'll have something that sulfation will come into play. And a battery that sits for a period of time that hasn't been charged and it's only half charged will actually sulfate, create sulfation on those plates.
Okay, so if you've got a lead acid battery, its optimal storage condition is fully charged.
Absolutely. It's
Right.
actually, it's fully charged with the charger on it, to be honest.
Right, so
That's-
trickling in.
Absolutely. So an
So it's-
automatic charger that can actually keep the balance sort of working there.
All right, so this isn't part of what I wanted to talk to you about. It just occurred to me. I know that if you've got a cold cranking battery and it goes flat for whatever reason, like in the olden days you would have left the headlights on or something.
Yes.
And in the modern era, it's probably just running a whole bunch of shit in the background, right?
That's right, yes.
Is that another sulfation type failure that kills it quickly, or why do cold cranking batteries die when you run them flat?
The chemistry. The internal chemistry does not like to be run flat. So any battery, even that it's brand new, if it's run flat even once, it's degraded its life expectancy, certainly.
Yeah, right.
It may not happen today, may not happen tomorrow, but it will reduce the performance. And we've heard of car batteries lasting 5 or 6 years sometimes, and under the right conditions they will last, but you can hear a battery going flat in a year or 12 or under 24 month typical period.
Yeah, right.
And that's unusual, but a battery like that is where it hasn't been looked after from day one.
So really bad to have you've got your daily driver, and then you got your weekend car that might not actually get used for a month. You'd want to have that on a trickle charger.
You do.
Yep.
Yeah, and an automatic trickle charger too.
Right.
So you get a nice automatic trickle charger.
Just putting 1 amp in there.
That's right. And now what it'll do is actually it'll apply the correct amount of charge to the battery. So even if it's a bit low, and I suggest having a slightly higher amperage unit, not a super low one, because super low also creates sulfation on the plate. So having 1 or 2 amps trickle in is not the best idea. It's actually good to get a good amount, 10 or 15 amps straight into this unit, get the voltage up
and then maintain it.
And it'll maintain it. And then the system will go into what we call float. It'll rest back down again. The charger will monitor the battery voltage. Once it reduces down again, it'll kick back on, put it back into absorption, let it recoup some of that energy and let it rest again.
Yeah.
And that way the battery can last for extended periods of time.
So just channeling my mechanical deficiency again. If you're going to use this machine or any other device to test a battery, I'm presuming that you should only test a battery for its state of health when it's fully charged. Like
Always.
if it's a bit flat, you're not going to get a decent result out of that, and not indicative performance result.
No, if it's flat, with a unit like this, we can test it comfortably, even if it's, let's say it's 80% discharged or 70% discharged, you're still going to get a reasonable output performance.
Yeah.
It'll give you an idea of how well the battery will perform versus an electronic tester where the results could be anything at that stage, right? So here we can still understand, well, okay, the battery is sort of sitting at 12.3 or 12.4 volts, which is about half or 50% of the charge, but we can still load it and we can still see that, at minimum voltage, what the output is. And we'll find out whether the battery is still in reasonably good condition or not.
Okay, so to recap, the procedure for this is you just connect red to red and black to black. You crank up the rheostat until the voltage drops to where the big black arrow is on the dial.
That's right.
And then you read the amps directly off there.
That's right.
There's like Ohm's law with a carry handle.
Exactly. That's
Okay.
exactly right. Simple as that.
All right, well, let's test a few, shall we?
Yeah,
And
absolutely.
You can talk me through it, and you can come with us around there and have a look this way while we do that. Right, Frank, this is a fairly swish-looking battery here. Talk me through what it is.
So we've got an Optima spiral AGM battery here today. It's one of the premium batteries on the market. It's a fantastic unit. It's our test guinea pig today.
Okay, so the label's telling me 815 cold cranking amps. So that's what we're going to look for, I
That's
assume.
what we're going to look for today, yes.
All right, so let's test it or die in the attempt.
Okay, let's give it a go. We'll hook up our cables first of all.
Yep.
And obviously we've...
So we can see that we're at whatever we are, 12 and a bit, nearly 13 volts. Sort of
that's
thing.
right, yes.
Yep.
We're in that area there. So what we're going to do is we're going to be dialing in 815 cold cranking amps. So right into that, just above that 800 mark there on the meter.
Right. So this, so the amp scale it doesn't change. Whereas we've got to read the right voltage scale here for 2412 or 6.
That's correct.
So the middle scale is telling us 12 and a bit.
That's exactly
Beautiful.
right.
And that tells us the battery's charged.
Exactly. So
Right, okay.
the battery's looking good. We're at just under 12.5 volts, or around 12.5 volts there, which is perfect. We've got our selector set in the correct 12 volt position.
Yeah.
We're going to look good. What we're going to do now is we're going to dial in a load, and we're going to dial in right up to that 800 mark, and then we're going to look at where this needle moves to, and we're going to make sure that this needle is actually on the right-hand side of that little triangle there. That triangle is our minimum volt marker, and that is the minimum volts that the battery can sustain its maximum load.
Okay. Let's do it, or disappear in a pile of white light.
We'll start loading up.
Okay. Yeah, right, okay.
And
So
as
there
we can
go.
see,
800 and a bit.
yep,
Like, there we
800
go.
and a bit, and we're right on that marker there.
Beautiful. So you wouldn't want to leave it like that for half an hour.
No, Typically 10 or 15 seconds is the test, and that's it. It's as quick as and easy as that.
Yeah, right. So I noticed that you're up here dialing in the 815 and then checking the position of the battery. Could you do it by just dialing up the rheostat until you drop to the minimum voltage and read the current? Is that,
Absolutely, we can do it that way too. That way we're actually testing the maximum performance of the battery.
Right.
So by loading it that way, we just load it here and we can say, right, okay, so
Wow, here we go.
we can see that
1,000 amps,
that's
1,000
right.
and a bit.
That's right. So as that just comes creeping over,
Yeah.
we're getting right down to that 1,000 amp mark, and that's probably where that maximum cranking amps number is actually rated there for.
I noticed when you started, the first time you cranked the load up here, this terminal, which is quite firmly affixed, started to move. So there is actually a fair bit of actual energy movement taking place, right?
That's absolutely correct. You know, we are moving, 400 or 500 amps around here.
Yeah.
Right. So that's substantial power.
Right. So so that's another thing to bear in mind. It's the cold cranking amps isn't the actual number of amps moving through the wires.
Correct.
It's you got the actual number of amps moving in the wires equivalent to or approximating cold cranking amps.
That's correct.
And that's why these scales are 2 for 1.
Exactly correct.
Cold cranking amps versus amps in the wire.
That's right.
Okay.
That's right. So, I like to test batteries with amps because to me that's the true thing. So if we've got an alternator, the alternator is not based on cold cranking amps, it's based on amps. So we know that the alternator may need 100 or 200 or 300 amps to turn over.
Yeah.
And that's the way I like to test batteries. It's a more of a precise number.
Okay, but the battery has CCA actually written on it. So
It
if
does.
you're testing a battery, you probably want to...
Exactly.
Right.
Test it with what the specification is.
Yeah.
So the OEM specification is CCA, but it's not always CCA.
Right.
So you will have batteries that will have CA on there as well.
Right.
So CA is cranking amps, and therefore we'll be using the top gauge on there.
Okay.
And then there's batteries that don't have any of that and have amp hours, and then we can actually use the bottom gauge to test that.
Okay, so it strikes me that a monkey cannot successfully do this. You have to actually understand a lot of the nuance
You do.
about the performance of the system
Correct.
in order to get a decent result.
Yes.
It's just that we're not using a proxy here, we're using actual heavy load.
That's right. Actual results.
Have you got a dud battery we can check?
Let's try one of these batteries over here.
Righto, let's do that.
So interestingly enough, this is a new battery.
So this is a brand spanker.
This is a brand spanking new battery.
Okay, well, based on what you've told me, I'm getting the distinct vibe that this battery is fully charged because it's right up there near 13
Yes.
and we're connected the right way, and we should be getting what? It's just 1,000.
1,000.
1,000 cold cranking amps.
That's right.
All right.
So 1,000 cold cranking amps is going to be that midway marker between 800 and a 1,200 there, basically.
Okay.
So let's see if we can get there. Well, we can, but look at where the voltage marker is. It's way beyond.
Yeah.
It's way beyond that marker there.
Okay,
so it's gone.
So this battery has a problem because it seems fully charged.
It does. It seems fully charged, and
it's brand new. So
it
we
is
can't
brand new.
we
That's
can't
right.
attribute this to any sort of abuse in service.
No, this is a brand new, delivered, ready to be used.
Yep.
So let's actually test. So now we know that it's no good, and we know that we can get 1,000 CCAs out of it.
Yeah, but by overloading it.
By overloading it.
Yeah,
But let's actually test to see what the actual voltage is.
Yeah,
so
yeah.
now we're going to bring that needle right down to the min voltage marker, which is right there, and we're only reading
500 or 600.
about 600. There we go.
Yeah.
So
So
that's
it's
unsatisfactory.
significantly sick. It's like
Absolutely.
only operating at 60% of its hypothetical maximum.
That's right. And that's a battery you do not want in your car.
Yeah, so you've paid hundreds of dollars for this off the bat, and
That's right.
it's dead before you've cranked your car.
That's
basically.
exactly right, yeah.
Measuring that cranking current directly is pretty clearly the best and most definitive cranking battery test. I wanted to do this story for you for two reasons, right? Firstly, if your battery just craps out, but the dealership or your mechanic tells you, she's all good, mate, you now know, A, to ask them if they actually put that battery under load to test it, or did they just measure the internal resistance, and B, to find a shop that actually tests your battery under load to avoid these misdiagnoses. The second reason is if you run a service department or a workshop, it might be high time that you thought about how you test your customers' batteries. Every false diagnosis of good battery health that you deliver is a reason for that customer to shop around for someone who they perceive as being more reliable than you. And I don't know too many automotive businesses that can afford to bleed customers like that in the current economic climate. Those Durst battery testers, to be fair, and I'll put links in the description if you want to check them out, they're probably outside the budget for individuals like us in our sheds and our garages, but that's certainly not the case if you operate in a busy servicing environment. And I'd argue that if you retain just one or two customers whom you might otherwise have lost through this process, those battery testers would have obviously just paid for themselves. They're made in Australia too, and that is increasingly important, at least it is to me. And I kind of like the Apollo vibe that they've got going on. I would put one here in the Fat Cave tomorrow for that reason alone. I'm funny like that, but hey, maybe you see it my way too. Now, actually, at the risk of not being totally flippant for just 1 second, doing that manual process, cranking the rheostat by hand and watching the needles and interpreting what their movement actually means, tells you a great deal more about the battery than, I would argue, being a monkey and waiting for a green LED on a panel and or some sort of pleasant, vaguely Asian chime to emit from the machine, and maybe even a printout or a PDF being sent to your phone by an app. Perhaps I'm just showing my age now, and it is significant. You can check out Durst products at durst.com.au. That's D-U-R-S-T. That's 793 dump truck in the backyard, dude. I know you thought it was a great idea, and it was. Ex-wife number 3 might have disagreed strenuously. That's why she's ex-wife number 3. You really should fire that dump truck up next Sunday morning about 6 a.m. Let it idle for a few hours. See what the neighbours have to say. Suburban bliss. Durst makes pretty cool toys for heavy industry and transport, right? And the other thing about Made in Australia, apart from having local support, like you get a dude who knows about the product actually answering the phone if you have to ring for some reason for a spare part or something, as opposed to just dealing with a chatbot in Shanghai. The other thing about Made in Australia is when you make stuff here onshore, there is a brains trust here. Dudes like Frank, proper brainiacs who know the tech backwards, who can lift the lid for us, right? If we lose that, it's all just politicians and bean counters and delivery truck drivers from coast to coast, and nobody wants that. I'm pretty sure we can't compete at scale with the Chinese. That race has been run pretty clearly. We lost. So I actually think the future of manufacturing in Australia rests with operations like Durst, right? Specialist niches where you need bespoke tech-savvy solutions to ongoing local problems. You know, the kinds of stuff that keep the joint running. I'll put some links to some cool Durst toys in the description. They've actually just designed a modular rapid response rover for evaluating hostile environments such as mediation conferences with ex-wives. You get the feed in 4K too, which is better than being there. Ask me how I know, dude. You could probably also use them in a less dangerous situation, such as, I don't know, a catastrophic mine collapse. And they're made in Australia, dude. Come on, patriotism. And that Cat 793 Hyperstart jump starter, I freaking want one of those, dude. I so do. I have absolutely no use for a jump starter that preposterously over the top, and yet when I look at it, it's actual engineering porn. I'm powerless, dude. Like, this is my kryptonite. I love that stuff. And you will too. You sick, sick bastard.